my name is Nazeer from the Faculty of Civil Engineering Technology, and I will be presenting to you the ellipse, the parts of the ellipse, and the equation for the ellipse. Now, you need to know the parts of the ellipse and the equation for the ellipse to actually solve elliptical problems. Okay, I hope that you have fun with the presentation. As you could see, the shape that we have on the screen is an ellipse. It is an egg shape, but a lot more symmetrical than an egg. It has a major axis along the length of it and a minor axis along the width of it. When we look at the major axis, we have two vertices, we have a center, and 1/2 of the major axis is dictated as the variable a. So if we have 2a, we have the entire major axis. Okay? When we look at the minor axis, it intercepts the major axis at a perpendicular and the perimeter of the ellipse also, and those are called co-vertex. Okay, that's the minor axis, and 1/2 of the minor axis is dictated as the variable b. So if we have 2b, we have the entire length of the minor axis. We have two foci or focuses in the ellipse. When we look at a parabola, it also has a focus. So an ellipse is very similar to that. We have two focuses, and when we look at the distance from the center to the focus, center to the focus is dictated as the variable c. We now could see that if we were to create a triangle in here, we would have a right triangle because we have a perpendicular at this location. The other thing that we should keep in mind is that the length from the co-vertex to the focus is dictated as the variable a prime. Now it's dictated as a prime for a particular reason. A and a prime is the same length. They're not the same distance. I mean, a is from the vertex to the center, and this is from the co-vertex to the focus, but they are the same magnitude of number. Okay, they're the same magnitude. It is a phenomenon of the ellipse, and each one of the conical shape, like when we look at the parabola also, it has its own set of rules. When we look at the equation of the ellipse, we see it resembles the circle quite a bit because of the x square and the y square. But now we have denominators of a and b squares. Okay? The x and y here represent the coordinate point on the ellipse. Okay, so if we have a coordinate, x and y value, that lands on the perimeter of the ellipse, we could substitute those numbers in here. And of course, 1/2 of the major axis, 1/2 of the minor axis are your a and b respectively. Now, the difference between the first equation here and the second one is just the location of a and b. They have switched positions. Okay? And there's a reason for that. In this first equation here, we know that the major axis is along the x-axis. It is running horizontally. Okay? Likewise, in the second equation, the a switched position, it is the denominator of the y squared value now. Okay? It is the it means that the major axis is running vertically and it coincides with the y-axis. The reason why it coincides with the y-axis and the x-axis is because we don't have h and k variables in here. You saw that h and k both in the parabola and in the circle when the center or the vertex was not at the origin. Okay, again, this indicates that these centers or the center of this ellipse is at the origin because of the absence of h and k. In this particular slide, it's just showing that the a and b's are switching. We know that the x and y is a coordinate value on the ellipse, A is 1/2 of the major axis and B is 1/2 of the minor axis. When we look at this orientation, the ellipse is oriented with the major axis in the vertical position, coinciding with the y-axis. Okay, we still have all the parts as if it was oriented horizontally. We have the center, we have the vertex along the major axis. The focus is also only on the major axis. It's never on the minor axis. So if you're given focal points, you know that you have your major axis also. Okay, and you have your co-vertices over here. When we look at satellite dishes, when we look at headlamps of cars, you could see that in technology, it's important to locate the focuses of shapes, of conical shapes. Because we have a 90-degree here, and we have the distance from the co-vertex to the focus equaling the A value, we could create a right triangle. We could create a right triangle. We know that this is a 90-degree here. We know the length of this. So then when we use Pythagoras theorem, we have this value, we have this value, we could solve for that one. Remember that C is not dictated as the hypotenuse, so it is A is the variable that's the hypotenuse. So I'm going to take the root of A squared minus B squared. It'll give me the value of C. Okay, the root of A squared minus B squared. And here we have an equation. It is an ellipse equation, but it has the H and K in there now, and this indicates that we don't have the center of the ellipse at the origin. Now the rest of this will be done in class. We will do lots of problems to get you familiar with how to solve elliptical problems. That's all I have for you. Thank you very much. I hope that this lesson helps you with your work. Bye-bye.